Good evening, folks. Welcome to the 989th monthly meeting. We have a great speaker here, Nico Carver. He's one of the people who also inspired me to get into this photography area. So thank you, Nico, for coming today. From the UMass side, there was a talk this Monday. The chair of the Rochelle Society from London, he had expressed in collaboration with some, I'm not exactly sure how, but he extended some interest. And the UMass team, the astronomy group, the faculty, the professor there said that the students there will be interested. However, they can collaborate with us and utilizing our scopes, doing research work and so forth. Also at that meeting, I met the president of the New Hampshire Astro Club. So he expressed also interest in an overlapping interest. They have a dark sky area in White Mountain area, if I'm right. And they were saying we could use theirs. They can also use the clubhouse area. We have something to be discussed. So we'll discuss it later. There was also a thought from some members, one of the members here, to reorganize our monthly meeting, how it happens, we will discuss. We'll have a committee to form in terms of the timing of the meeting. Some people said we run too late into the night. If we could start earlier than 8 o'clock, if we could switch the talk and the business meeting, so on and so forth. So we'll get it out and we'll discuss at the meeting. So these are the main points I wanted to bring up.
Come on, two old guys coming out of their seats.
Lord, it's terrible.
I
forgot my walker.
All right, well, hi, everybody, how's it going? It's the fall, it's awesome. Skies are clear, the air is somewhat steady. Oh, one correction to the mirror making activities. There are now 5 successfully completed mirrors. Willie Ho. Willie Ho last night, after many setbacks, his mirror is now complete. It's about a 16th of a wave, with a straw ratio of about 96%. So he was toying for a moment to try to make it better, and I think Phil and I successfully talked him out of that. Want to make it 8 setbacks, maybe a dozen? No, I said stop. So anyway, here's the observing committee report. It's back in the news again. The Supermans are out there, right? There'll be a few more this year. So I found this cartoon on the internet, and I thought, I kind of like to think the moon is super every night.
Mario's not here.
No, Mario's not here. I should have saved it. I would like to.
I am here and I'm not happy. Thank you.
You look that guy. Well, then you appreciate the humor. But let's get on with things. So we did have a couple more Titan shadow transits since the last meeting. And remarkably, I think this was the 5th and 6th of the series this summer. All clear skies for these things. Yeah. I couldn't believe it. New England skies never do that to us. But the last one was particularly challenging because at mid-transit, it was only at mid-transit where the entire shadow of Titan was on the disk. I was using my C9.25. I could actually see Titan on the disk, silhouetted against the disk. And during moments of exceptional seeing, which are few and far between, I could see the shadow of Titan. And that'll do it. There'll be more Titan transits, but no more shadow transits until late 2038. So stay tuned for that. We'll talk about that when we get there. There you go. Next slide, please. And so Sal Larisha sent in that image. Venu took that image. Here are some nice shots from John Boudreau using his 14.5-inch film Kirkman. And you can see how far north the shadow was on this transit. It was really challenging to observe it. I will, at least from my backyard, the air was remarkably steady that morning. And I was able to get some pretty good views of it.
So the shadow's elliptical?
Of course. Yeah. Well, you would imagine it would be, it's kind of like foreshortened as it cut into the northern latitudes. Yeah. And you have the next slide. And here's some Justin Lutz in Concord imaged Titan on the disk at about 10:36 the night of that transit. And just to prove it to be true, there's a shot of Sky Safari showing where Titan was or expected to be at the exact same time. So Justin did a nice job of capturing Titan. Now, when I looked at the shadow transit, Titan was nowhere near that contrasting. I knew where to look for it and I could barely see it, but there wasn't a lot of contrast. So it was a really challenging observation. But that's a great shot. Thanks, Justin. How about the next slide? Planets. So Mercury and Mars are really low in the southwest after sunset, and they're virtually unobservable. It's not a good time of year to be looking at things along the ecliptic after sunset. The ecliptic now is making a really shallow angle relative to the horizon, and so these would be too challenging objects to look for. Venus, on the other hand, is still a morning object, and I encourage you to try daytime telescopic observations. It's currently at minus magnitude 3.9, only an apparent diameter of 10 arc seconds, so it's pretty small. As it rounds away, goes around back of the sun from us, it's 23 degrees away from the sun, and superior conjunction comes on the 6th of January, when it will be unobservable by them. I don't think it'll be directly behind the sun, but pretty close. So catch it while you can.
You know where I go for the record?
I could try, I might. Jupiter's currently at minus 2.2, rising about 1:30 in the morning, transiting right about sunrise. So we're getting there. Opposition won't come until January. Next slide, please. Oh, you broke it, huh? Oh, there we go. If you haven't looked at Uranus in a while, this is a great year to do it because it's a pretty easy object to find right now. At magnitude 5.7. It's just this kind of a view rising up in the east with 37 tau and Uranus forming a nice little triangle with the Pleiades. There's nothing else bright in that part of the sky, so it's a pretty easy find. And with an apparent disk of 3.8 arc seconds, you should be able to see that oddly colored disk of the planet. The moons are a little challenging. They're bright, but the planet's also very bright. And the moons of it are pretty challenging to see, but go for it. Easy to find. Next slide. I was playing with his phone over there. While you're looking at the outer solar system, go catch a look at Neptune. It's remarkably closely aligned with Saturn this fall, at least for now. And so it's within a 5-degree finder scope field. It's faint, but it's pretty easy to find. We've been showing it off at some of the star parties. I tell people it's probably the least impressive thing you're going to see all night, but none of your friends have ever seen the planet Neptune. I also sometimes remark that someone will set up the telescope and I'll say, you probably woke up this morning and thought to yourself, my life would be complete only if I could see Neptune. And that's why you want to come to star parties. So check it out. It's faint, but you can see it. If you come to the clubhouse and we're operating the 25-inch, you can see the moon Triton. I can't remember, was it about a week ago, Steve? Yeah. We were up there and the air was really steady and Triton was just jumping out at us in the 25. It was pretty easy to see. It's around 13.6 magnitude. It's pretty faint, but we can see it. And of course, Saturn is still the show of the evening. Still relatively faint because the rings are tilted only 1.2 degrees to our line of sight. It's transiting about 11:30 at night, 800 million miles away. And if you wait until mid-November, which is only a month away, the rings are going to be about 0.4 degrees. And it'll be interesting to see where do they disappear in the aperture of telescopes? If you look at it with a 60-millimeter refractor, will you be able to see the rings? Maybe it's an 80, maybe it's a 4-inch, maybe it's a 6-inch telescope. It'll be interesting to sort of compile like a survey of that. So if you've got a certain aperture in mid-November, check it out, see what you can see, send us an email, and we'll compile some data. All right, just to see what we can see.
I'll just jump in. This is a great time to look for Saturn's moons because the rings aren't going to be causing any extra light. So if there's moons you haven't seen before with a certain aperture telescope, give that a try too.
And just like with Jupiter's moons, they're all pretty much in a line right now because we're looking at the plane of the Saturnian system. And so they're easy to see. They just seem to line up on either side of the ring. So pretty fun, actually. Get out there and check that out. All right, next slide. All right, so hey, Mario, this is for you. The lunar highlight of the month. I wanted to go back to Nectaris. This is a little bit overexposed here, but you can see what we're talking about. But recently, we talked about the craters Theophilus and Cyrillus and Katharina. But Nectaris is a really nice ancient impact basin. The Altai Scarp is actually one of the mountain rings that formed when the impact occurred. Coming later was Fracastorius and Piccolomini. They're really nice craters to look at. And if you really want to see the Altai Scarp, or make it really look like a scar, catch it on the waning moon. Catch it as a gibbous moon after full moon. The shadow is favorable to make it look like it's truly a scarp, like it looks like cliffs. It's pretty cool. So that's something to, get out there and putz around with the moon, have fun with the moon, always have fun with the moon. Next slide, please. We have some occultations coming up. When you go home tonight, break out a telescope, because between 11:30 and 12:30, the moon will cover some of the stars of the Pleiades. And then later in the month, on Thursday, October 30th, the 2.9 magnitude Deneb Algiva will be covered by the moon. That's, I can't remember which star it is. It's in Capricornus, I think. But that's a pretty bright occultation to happen. So pencil those in and get out there if it's clear. All right, next slide. We got now. Oh, the double star of the month. Here, you're a double star guy. You talk about this.
Never saw this one. No, Alpha Pisces, this is a really nice double star. It's very close. It's only a little less than 2 arc seconds apart, so it's kind of a challenge for small aperture telescopes. I split it with my little 3-inch back around 1971. They were about 1.8 arc seconds apart then. It's got a long orbital period, something like between 700 and 900 years. And right now it's near what they call apostron, or apostron. How do you pronounce that? I'm not like a president that couldn't pronounce the name of that drug, but anyway, they're very close together, so it's a good challenge for a small scope. They're both A-type stars. And I would use about 150, 200 power to check them out. As far as the colors, an A-type star should be white. But since these are different in magnitude, sometimes there's a contrast effect. So you might see the brighter component is white, which is what I see. The fainter one sometimes will look more like a bluish color. So that might be the fun thing. Just see what colors you see when you check that one out. But that's a nice one to look for. I guess we can go to the next slide and get the variable star of the month, right?
Talk about that. You like talking about these.
Okay. Well, again, I'm kind of limited. My wife is still recovering from her cancer surgery. So it's been hard for me to get out for very long periods of time. I'd like to get back. And years ago, we did an Algol watch, where I hand out some little sheets, data sheets. We kept track of Algol's change. It goes from magnitude 2.1 to about 3.4. And the entire eclipse takes about 8 hours, but the guts of the eclipse is about a 3-hour span. So we've been able to go for about 4 hours and get the whole thing. So I'd like to do that. I'll put an announcement. Again, it depends on how my wife is recuperating and when I can get out for a couple of hours to check that one out. But that's a really neat variable star, because you can see the action again in just a matter of a couple of hours. So I'll put something out. I did check a tentative date. Let me get my glasses on so I can read my own notes. There's going to be a very favorable one on November 28th. And that's going to be, the maximum will be about 8:45. So we can start at about, say, 6 o'clock. We catch everything at that time. So again, stay tuned on that one.
All right, next slide.
Now I think we get the observing committee to.
No, don't forget the Orion meteor shower.
Oh, yeah.
Little specks and bits of Halley's Comet. It's not a great shower, but if you happen to be out looking at other things and you notice there are extra meteors in the sky, they are likely from the Orionid meteor shower. Yeah, bits and pieces of the Halley's Comet. All right, next slide. Comet Lemon is currently in the hind legs of the Great Bear. It's about 6 magnitude right now and brightening. I think it's really a morning object, but it might be worth getting out there and take a peek at it, or take some pictures of it. Get the images out there to take a look at it. I think the next slide is the graph of the predicted brightness. That X is where it's going to be closest to the Earth on the 27th of October. And in Boötes. But if you go to the next slide, you can look to see what the brightness estimates are going to be. Remember David Levy's quote about comets, right? You've all heard it. Comets are exactly what they're just like cats. They all have tails and they do exactly what they want to do, right? So we can hope it reaches magnitude 3, but it will do what it will do. And so, but I thought that was a nice encouraging sort of plot there. So, so fingers crossed that it treats us well. All right, next slide, next slide. This is a Doug Paul image of the comet. You see that nice green glow from diatomic carbon. Remember chemistry class, you guys? Everybody took chemistry at one point, right? Try and draw a Lewis structure for C2. Can't be done. It's an exotic compound, yeah, it's very, yeah. Can't be done. Anyway, that's a great shot. Doug, are you here tonight? Where's Doug?
Yeah,
Comment?
that was a sequence of 60 1-minute images. Do you have a video or?
Yeah,
Okay.
Venom has it on his computer. Let's see if we can get it
Okay,
right.
these are the, pretty much the raw, stretch, but other than that, hubs.
What is the focal length?
6-inch aperture, 1200 millimeter focal length.
Okay.
Thank you.
Oh, look at that. Wow. Nice job.
Yeah, that's pretty. Look at that.
If you watch the first image real quickly, you can see a satellite shoot across
No
the
way.
right corner.
No way.
Oh, they're all.
Oh, yeah.
That's propped, the full frame will show you more.
All right, let's see what the next slide has to offer. Oh, more. There you go. That was a satellite, wasn't it? When we observe, I don't know your experience, my own personal experiences, almost every night when I look through my telescope, almost any magnification, there are always satellites that are tracking through the eyepiece field, especially right after sunset, or early in the morning. You know, when you get to about midnight, think about it's all about the shadow of the earth, right? And as we get towards the winter solstice, at midnight, we're deep in the well of the Earth's shadow, so you don't see many satellites. They're up there, but we just don't see them. But in the hour or two, 3 before and after sunset, the sky is just filled with those things. All right, go ahead. Here's
Okay.
which month is this? September.
This is the last month. We have this last month, this month, and next month. They're all far south objects. And the first one is NGC 6540. It's a globular cluster in Sagittarius, not too far from the spout of the teapot. And it's only about 9th magnitude, which still isn't bad as far even for a small telescope, but it's right near the galactic center. And if you look at that image from Doug, the cluster is that little clump right there. So I'm gonna be honest, I didn't even try for it. First of all, when the time I was looking for it, oh, we had a pointer? Of course, I was carrying. Oh, wow. Right there. The problem is you can't translate. The people that are on Zoom don't get to see that stuff, but it's right there.
Turn the lights back up so we can see the pointer.
Nah, I won't help you. Right there. I'm blocking, it's on my fist right now. There, I'm covering that whole globular cluster. And Herschel discovered it, and when he did, I think he kind of categorized it as he mentioned that it was resolvable. And what he saw, actually, there's so many stars, there are some Milky Way stars, foreground stars, that are in the way of that. The actual cluster, I think, Steve O'Meara said, what you want to look for something that would be like a 5 arc-minute across comet with about a arc-minute across nucleus. That's what you're basically looking for. So it's very small, very faint. And we had, obviously, not very many people were able to get images of it. We'll go to the next two. I think we got one from Mario, and I think Doug had an upgraded one. Is that Mario? Yeah. So you see what we're talking about? It's this tiny little thing right there. There's the main part of the cluster. And these stars around it pretty much are Milky Way stars in the foreground. And then I think we still get Doug's updated one. Let's see.
Yeah, but this didn't come out very well.
No, that one was a very hard one to
Yeah, it didn't.
process the whole.
Yeah. But it's right in the middle.
I'm seeing it, but that was very grainy right there. And then you can see the Milky. This is what probably Herschel was thinking he saw when he thought he resolved it.
The Palomar clusters, you know, think about the name Palomar, right? These were discovered late in the game. They're really faint. Palomar clusters are really hard to see.
Okay, and then next, this would be this month, I believe, the Helix Nebula. And this Doug Paul is a preliminary image. And again, this is about minus 20 degrees. It's a far south object. Now, you notice we just had only 2 for the last one, September. So this one, I don't think, is anybody even interested in this thing?
Well, I am. I just told Steve, I rummaged through some of the stuff at the clubhouse and found an 1.25 inch Orion sky glow filter. And we're gonna put it in the finder scope and see if we can see it with the 80 millimeter finder scope.
Good.
So again, sometimes these extended faint objects are better seen in small wide field telescopes. If you can get to, especially if you get to a dark sky, or if you can employ like a gentle filter like the sky glow. I'm not sure I'd throw a UHC on a small aperture or worse, an Oxy 3, because you're not gonna drive light, you're not gonna drive any light through the filter, right? They're too constricted, they're too narrow banded. But a sky glow filter, if you have one, pop it in your lowest aperture device and see what you can see. It's about half the size of a full moon, it's big. Yes, sir.
I had some luck a few years ago at the clubhouse with seeing it with a 10-inch f5 with I think I had a 35 millimeter eyepiece in there.
Yeah, you want a low power.
Yeah, so that's like almost a 2-degree field of view. So, but yeah, the challenge was finding the dog because there's nothing that far south, and with the sky glow, it's hard to find anything.
Yeah, it's hard to star hop to it. It seems to be in like just out in the middle of nowhere. But use a good finder chart, and you can. I like Steve. You like to try to get there from the stars of Capricornus. I like to get there from the stars of Aquarius. But all roads lead to 7293, of course. Anyway, that's a great shot. I love it. But yeah, try it. You definitely need filters for that one.
And again, I saw it my first time with that little 3-inch Edmund telescope. And the first time I saw it was 1981 Stellarphane, the nice dark skies of Stellarphane. That same night was the first time, actually I'd be able to see that one. I also saw it with a 4-inch telescope, with 4-inch f8. Again, low power. What I want to do now is both times I saw it, I did not see the annular shape. To me, the whole thing was glazed over. So I'm going to try with my Astroskin. That's a 4-inch Richfield telescope. And an 03 filter, see if I can at least see that it's annular in shape. But I was joking around, but I think we should get a ton of observations of this. Maybe Slav can do a visual, make a sketch. He's been doing some sketches for us. I'll try to show some sketches too. And finally, we have next month.
This is a good one.
Oh, we'll get a ton on this one. This one is minus 39 degrees. So unless you're looking, if you've chopped out all the trees in your southern horizon, you're not going to be able to see this one. And then you have to deal with atmospheric extinction. It's about a 7th or 8th magnitude galaxy as is. So we'll probably lose a couple of magnitudes at that depth. And I'm just researching on it now, but apparently in dimensions, it's something like 30-something arc seconds or arc minutes by 6. That's the width of the moon. So that much light spread out. I don't know how well we're going to do with this one. I know, Doug, you've already said it's just a little low for you to image. Mario, it's
to me. In fact, that's probably.
it is.
That picture was taken by Adrian from New Zealand.
Oh, that was the one with the other one, the one that you took?
Right. Now, that was taken by Adrian. I processed it, but that's from New Zealand. That's why it's so distinct.
Okay, and that's probably my fault. I didn't put, we got it all mixed up now. Doug didn't take it. Mario didn't take it. A guy outside the club took it. So we want something from the club when we show this thing.
Well, I did send you one from up here that I took. I'm going to try to retake it before November. But it's a tough object because it's so low in the sky here. But that one is from New Zealand where it's straight up overhead.
Okay, yeah, he sent me 2 and I got the wrong one there. But and his was actually better than this one. So we'll see improvement there.
If you're going to try for it, again, I would try a low power telescope. Filters aren't going to help you with galaxies, but try to get to as dark a sky as possible and use a nice wide field. Like we said, it's 31 arc minutes on the long side. It's really big, and that's really challenging. I was surprised that Kepler and Sander gave it 5 stars. I would never do that thing 5 stars. It's probably impossible. But here's the really good news about the Observer's Challenge. We are almost done with the current Observing Challenge list. We're going to go back to 2009 for next year, which means you won't be seeing things like NGC 55 because that's almost impossible. Going back to a time in the days where the challenges were challenging but not impossible. So, there is hope coming down the pipe. So I hopefully inspire you all to get out and do as much observing as possible. Some of these things are really quite difficult from urban settings, but go out and give it a shot, right? You never know what you're going to see, especially the faint things. There's a quote that's attributed to Michael Covington, but he claims it's not his, that every galaxy deserves at least 15 minutes of observing. I know Roger Iverson and I, one night, were observing a very faint galaxy, and for the first 10 minutes, couldn't see it. And then all of a sudden, we started to see it. We could actually pick it up with our eyes. And by an hour in, it was really quite obvious. I don't know why that happens, but it happens. So don't be impatient with some of these faint objects. Give them some time and see what you can see. And
Yeah, go ahead.
you know, where do you want to get out of here?
Well, I'm gonna have to, we gotta take care of my wife.
All right, Joe.
I just wanted to say it's great to be back, and it's been a while, but I just wanted to tell you, you haven't aged a bit. You look old already. Keep looking up.
Thank you, Glenn. Thank you, Glenn. Well, it was a weird month for the phases of the moon. When we lay down the monthly schedule at the clubhouse, we try to do it around the dark of the moon weekends. And there are 3 of them this month that are sort of dark of the moon. So there they are, and we should be open for business weather permitting. So come on out and join us and have some fun.
So we have Nico Carver going to talk to us about the past 10 years of amateur astrophotography. Can't wait to hear it. Nico is a dedicated deep sky astrophotographer with a knack for teaching people complex software. He has taught Photoshop professionally in the past to the university level and nationally attended webinars. After discovering the joys of deep sky astrophotography in 2016, it quickly became an obsession. From 19 to 22, he worked at the HarvardSmithsonian Center for Astrophysics, where he helped preserve the early history of astrophotography through the project. How do you spell that? PHaEDRA, okay. Starting in 2023, he went full-time with astrophotography education, and his primary mission is helping beginners get started in the hobby. Nico's favorite objects to photograph are nebulae. Over to you.
Thank you for having me, and thank you, Venu, for inviting me down. So this is a new talk for me. I realized at some point this year that I've been doing this for about 10 years, and so I thought to sort of wind together a talk about my personal sort of history with amateur astrophotography with developments over the past 10 years. Because I think it's been a very exciting past decade to be an astrophotographer. So when I think back about when this really started for me, it was probably on this trip. I was a sort of crazy person and went to Iceland in December. Has anyone been to Iceland in the middle of the winter? No, for one person, okay. So most days it's just like blowing horizontal ice in your face. So when you go around and see the sights, it's not particularly nice. But I grew up in Minnesota, so I was sort of used to weather like this, and I actually really enjoyed the trip. And a big part of going in December was it's a better time to see the northern lights. I had previously seen them a little bit faintly in Alaska. I was working on a vegetable farm, but it was the summer. And so in Alaska, that far north, most of the night it's not really dark, but I could still see them a little bit towards the end of the summer. And I wanted to see them better, so I chose Iceland. And I was very lucky because on 2 different nights, it was clear and we had beautiful shows. I rented a car and we were just driving around, and just outside the window, I could see this off in the horizon. And then I got out of the car and it filled the entire night sky with color. This was another night, and it's a little dark on the screen here, but hopefully you can see this is what's called a glacier lagoon down here. And maybe you can see the stars sort of moving in the lagoon there. So this was a really famous spot actually for shooting the aurora. And I met a bunch of other photographers from all around the world there setting up. So it was sort of like my first star party, but I didn't know the word astrophotography. I was really more interested in filmmaking at the time. And so that's why I was doing these time-lapse shots. It wasn't until much, much later when I got home that I realized you could bring a single photo from one of those time lapse and bring it up in Photoshop, just pump up the exposure, and all of this color and detail came out of the shadows. So this, I think, was my first astrophotograph where I was sort of really trying to, or just experimenting and seeing what was there, and was just amazed at how much was in the shadow areas of the picture in a raw picture. Things came out that I didn't see in person, like you see right here, there's another glow over there. That's not the aurora. I found out later that was an active glow from a volcano in the middle of the island. So we were looking in towards the middle of the island here, and that's the glow from a volcano. So this is 2014. I don't really even count this as sort of my journey in astrophotography because, as I said, I was not an astronomer. I wasn't part of a club. I didn't know the word astrophotography. But over the next year or so, I did get more and more interested in stargazing and taking pictures of the Milky Way when I was out and about on trips and things like that. So these are a couple examples just of single pictures with the DSLR from dark sites. Then late in 2015, I don't know exactly what motivated me, but I decided I wanted to get into this. And I was living in Newark, Delaware, and it's a light polluted area. I decided I'd buy something, and I didn't know what to buy, but I was already a photographer. So I decided to buy just one device where I could use my existing photography gear and start shooting deep sky objects. So I picked this device right here. This is called an Astrotrack, and it was, I don't think that one's still available, but it was basically like a souped up barn door tracker, if you're familiar with the barn door tracker. It has a long threaded rod in here that moves this arm, and that's all it does to counteract the Earth's rotation. So, but it's motorized and it has a little, so you can power it, so you don't have to actually wind it like a barn door tracker. The downside to this is after about 90 minutes to 2 hours, it reaches the end of that threaded rod and you have to rewind it. And then when you rewind it, of course, anything that you're shooting is no longer framed up. So if you wanted to shoot something all night, it's a little inconvenient, but otherwise it works quite well. And the very first night I used it, I got this on my DSLR from a light polluted place, and I saw that color in Orion Nebula, and that's, I think, where I really got hooked. And from then on, it was just like every night I wanted to be out there under the stars shooting.
What size lens were you running?
This was a 70 to 300 millimeter zoom lens, and so
That's a zoom?
that's a zoom, and I don't remember what focal length I was at. Probably I was zoomed in all the way to 300.
Okay.
Yeah. And then I learned about processing that first week. The processing part came sort of naturally to me because I was teaching how to use multimedia software in my job. And so I started stacking pictures and having a lot of fun with that part of it too. Right after that, in January 2016, I found the Delaware Astronomical Society, which was a really great club and had a very active astrophotography special interest group. Led by Bill Hannigan here. And so they met every month. I really learned a lot there. And it was also a very open club in terms of sharing gear and all that kinds of things. So I was able to start using telescopes right away before buying one and things like that. The very first meeting, I'll always remember this, the discussion for that meeting was the quantum efficiency of CCD sensors. And I was just, it was completely over my head. I was like, whoa, I don't understand what you're talking about at all. But I now do. And the other thing I wanted to point out about this is even though I had no idea what they were talking about, the passion with which they were talking about this, it got me so excited. And I knew that I wanted to just dive in and really understand what this was all about firsthand. Why would I care about this graph? How does it relate to getting the pretty pictures and all of that? So it was really cool to see that people like really just dug into this stuff. Since this is going to come up later in my presentation, I'll just briefly explain for anyone who's not familiar with quantum efficiency, roughly what this means. So down here on the x-axis, you have the spectrum of light. These are the different wavelengths. So our eyes see in the visible wavelengths of light here from about 400 to 700 nanometers. And then over here, you have the infrared, the longer wavelengths. And then down here, you have the ultraviolet. And then these are different CCD sensors that were available at that time, commercially for like amateurs. And then these graphs are basically their quantum efficiency across wavelengths. You can see most of them peak in this sort of green, yellow area and then taper off in the infrared. what quantum efficiency is let's imagine you had a perfect sensor. It would have 100% quantum efficiency across all the wavelengths. It would be basically just a photon collector, or photon counter. So every photon that hit a photosite would be counted. The way quantum efficiency works is even the best CCD sensors have a peak quantum efficiency of about 80%. So at their best, they're counting about 8 out of 10 photons and converting them into an electrical signal that gets counted. If you get a scientific CCD, it could get even better. But you'll see that down here in the infrared, they drop off somewhere between 20 to 50%. So the reason I mention all this is it's going to come back a few more times in my talk. So quickly, I'd say down the rabbit hole. I started spending any like extra little income I had on some new piece of astronomy gear and finding dark sky sites around Delaware. So this is one of my favorites from that time. This was called Trap Pond State Park in southern Delaware. And there was a field in the middle of the park that they let me set up in. Here's some of my pictures from that first year. And what I was trying to do that first year was just, take it all in and try all kinds of different objects and techniques, which is what I recommend to anyone. So planetary, nebulae, galaxies, wide field, just try a bit of everything. This was my backyard sky, and this is Newark, Delaware. It's about equivalent to the sky here in Cambridge or Somerville. It's like a Bortle 8 sky. You could see Polaris, but you couldn't really make out the other stars in Ursa Minor. It was not very good. There was a lot of local light pollution too all around me. So I was often trying to set up like weird jerry-rigged like tarps and things to try to protect my setup a little bit from getting stray light. But I quickly realized sort of the benefit of going somewhere much darker. So I would often travel. This I think I took in West Virginia, which was about 4 hours away from Delaware. But I then heard, through the cloud, I heard about this idea of narrowband imaging, where instead of taking in lots of light, including the light pollution, and then trying to sort of subtract the light pollution out from your signal, you could just isolate these very particular signals and block all of this light pollution right as you're collecting the photons. And at the time, narrowband imaging was really something you did with mono cameras. It was before this sort of revolution now we have where you can use a color camera and dual narrowband filters, where you can collect both the HA and the O3 at the same time and then separate them out in software. At this time, you really needed to buy a black and white camera and buy separate filters. So it was a little bit more expensive, a little bit more of a big upfront cost, the biggest one that I had. But what I was really interested in doing with narrowband imaging was, of course, emission nebulae. Because with emission nebulae, you can isolate these different gases and then do mapped color imaging, which for me, as someone from sort of an artistic background, I found this really interesting to do these different kinds of color palettes and trying to bring out the different gas structures by using contrasting colors. So, like I said, at the time, the question wasn't really color versus mono as it is now. It was really CCD versus CMOS. And everyone in my club used CCD cameras. So they were all saying, this is the trusted thing. This is what we all use. This is what you should buy. Now CCDs are no longer available, so it's not even a question of which to buy. I ended up getting the CMOS just because it was like 1/3 the price. But it is an interesting thing where when you buy a new technology in astrophotography, a lot of times it's pretty untested. It's, you buy it just sort of hoping it's going to work well, but you might not, if it's brand new, you might not have that many example images to go off of. But I was pretty happy with it. It worked pretty well. I initially just bought the HA and O3 filters for it. I didn't buy even the RGB. because I just had enough to buy the camera and 2 filters, so I thought those would be the best bet. When I took this image in 2017, this was actually one of the first images that I took. I brought this into the club, and someone pointed out this little object down here, which I hadn't even seen. This is called the Soap Bubble Nebula, and they told me that this was actually discovered by an amateur in 2007 named Dave Jurasevich out of San Diego. And that blew my mind that amateurs were still finding nebulae recently. And so that was sort of a new obsession, right? It was just this idea that I could just be out doing my narrowband imaging in my backyard and maybe find a new nebula. And then I also really liked going after some of these dimmer nebulae that amateurs had found. I thought that was really cool to do. So this one, when I shot it in 2017, had only been found, I think, 5 years earlier by a French amateur. And it's called the Squid Nebula, this blue shape right here. And part of the reason this had not been found is just because this, behind it, this HA region, was quite bright, and they're much brighter than the O3 in front, right? And so if you just took a picture of this with a normal camera, you would never see it. You really needed to isolate this O3 and get a long integration. And so it's pretty amazing that it wasn't found, because this object is also huge in the night sky. This is like something like a 4-degree field here.
Can I ask a question?
Yeah. Go
So the squid that's in there is very difficult to photograph. I've tried even with an oxygen filter, which should be optimal. How did you get that photo? What filters did you use?
Sure. Yeah, I'll show it in, I think, the next slide. Yeah, here it is. So I used a 3 nanometer O3 filter and a 200 millimeter camera lens at f2.8. And I think that was part of my success there, was that it was a very wide, fast optic combined with a narrow filter. The Astrodon filters, this is getting a little technical, but they have what's called a flat top to them when you look at the response curve. So they can be used at f2.8. Some filters you need to actually buy shifted filters when you go that fast, but Astrodon filters, which I know this aren't even made anymore, they had a flat top, so you could actually use them with pretty fast optics.
And how much data did you collect for the oxygen expression? Because I tried to picture this, and I think I spent like 8-10 hours in that, and it was still, I mean, the H alpha was so overpowering the oxygen.
Yeah.
It was really hard to like bring the oxygen.
Yeah, I think it was maybe 10 or 12 hours just on the oxygen, something like that. The other thing I found, which is interesting, is, and this may be obvious to people who are already astroimagers, is that when you want to go after a really dim O3 object like that, you don't want to do it with any moonlight. Even moonlight will really mess up the contrast there. So I would use your new moon nights on the O3, even though that might seem a little bit odd, but because usually we think of, you can do the narrowband anytime, but with really dim O3 objects, I would wait for the new moon. Mm-hmm. So this setup that I put together in late 2017, I really, really liked. This was sort of my astro imaging dreams coming together, I think. It took a little bit of tweaking to get everything right. And at the same time, I found some techniques by a Finnish astrophotographer named J.P. Metsävainio. He had a blog, or he probably still does, called Astro Anarchy. And he was talking about this technique of removing the stars from the image, stretching just the nebula or just the deep sky object, and then adding the stars back in. And this technique is now really common, but it was the first time I had encountered it in 2017. And what I really liked about it was the old method that I was using was stretching the stars in the nebula at the same time and then trying to do star reduction techniques. And what I found was that the star reduction techniques, I always left all these little artifacts in my image when I zoomed in. Well, this method was a little bit cleaner. It allowed me to bring out the nebula more, and it worked really well for the kinds of things that I was going after. So then in 2018, I captured this one, which probably my favorite image to date, which was the Spaghetti Nebula, which is a large supernova remnant in Auriga, with this with that same setup of the 200mm lens. And I like this image so much that I 3D'd it. So I added a third dimension to the image. And this is an accurate 3D visualization. And what I mean by that is I actually looked up all of the distances from Earth to the different stars. All of this is readily available from sources like the CDS. And so if you know the distance in light years of all these stars from Earth, you can then, in a relative sense, put them on in the correct scale in the Z dimension when you're doing this kind of 3D effect. So it's a lot of work though, and I don't know if there's a better way to do it, but this is how I did it. I took each star and separated them out and put each star on its own layer in Photoshop, okay, and labeled each one. And then there's a program called After Effects, which is like a 3D rendering program. And I can import all of those layers from Photoshop and then put them accurately on the Z-axis so that when the camera moves in like that, you're getting an actual accurate representation of the stars in a third dimension.
Yeah.
I did not come up with this basic idea. I read it in a book. I'm a librarian by training, so I read a lot of astrophotography books. This idea came from the Astrophotography Manual by Chris Woodhouse, who I think is British. Around the same time, I started a YouTube channel, and I wasn't a huge watcher of YouTube, but I was teaching YouTube every day. I was teaching at the University of Delaware how to make videos and podcasts and things like that to the undergrads there. And when I started, we would have the students turn in their assignments on DVD. So they would have to make a video, burn a DVD, and then turn it in. And that's how we would then watch the assignments back. Eventually, like the DVD players were always breaking. It was a big hassle. So eventually we figured out, let's just have them turn these things in on YouTube, and that'll be easy. You can just send us an unlisted link and we can just watch them. So every day I was teaching people how to use YouTube, and I decided, you know what, I think it would be fun to just sort of start presenting topics on YouTube. So that's sort of why I got started. In 2018, I think I made 4 or 5 videos. Then in 2019, I stopped completely because I got a job right here at the CFA. It was a really great job. I was the librarian for collaborative programs at the Wolbach Library, which is no longer with us. But what I was doing was, you probably all know about the plate stacks here, the glass plates. There were notebooks associated with those glass plates. So if you look at like any picture, do I have one here? Yes. If you look at any picture of like the Harvard computers, looking at a glass plate, you'll always see on the desk next to them a notebook, as they're of course taking notes. All of those notebooks were just in boxes, waiting for us to like figure out, you know, what was going on with the actual notes they were taking and recreate the actual research they were doing. So what I was doing was doing crowdsourced projects, because this was all in like handwritten cursive and pencil. So we couldn't OCR these notebooks, but we wanted to know what they were saying. So I was doing crowdsourced projects to basically transcribe all those notebooks and extract valuable information from them, which was really interesting work. I was also a member of ATMoB and went to the clubhouse many times. This was a light pollution study I did there. During 2019, I think I was at the clubhouse a lot. I was working on this image of the Cave Nebula in Cepheus, and I was experimenting with new filters to me. I'd heard about these Sloan filters, which maybe some of you are familiar with. They're usually used for photometry, but I had seen an amateur on the Astro Imaging channel named Josh Smith, who was using them to find protostars and do different things with near IR filters. And so I thought that was a really interesting use case. I was trying it in more sort of big nebulous regions, hoping that I could bring out different nebulous structures that like basically seeing through the dark clouds of dust and things like that, and basically had no luck. And I look back on that now, and I think I know the reason why, and it goes back to this quantum efficiency idea. One advantage that the old CCDs had is that many of them were actually pretty efficient in the near infrared. And Josh Smith's CCD that he was using, I think, was one of these, where at like 750 nanometers, it was up at like an absolute QE of something like 40 to 50%. When you look at the QE curves of CMOS sensors, they were almost always presented in relative QE. So this could be deceptive because you think, oh, this looks great, but this is actually scaled so that the peak QE is at 100%, when the absolute QE was actually somewhere down here, 55 or 60%. Yeah. So that means in the near IR, I was actually like down here. So it made sense after I figured all of this out that like, oh, I wasn't really getting great results in the near IR with the camera that I was using, which was the ASI 1600.
Does that have any filters in the infrared range? I mean, you weren't running into a filter that was built into the camera, were you?
No, I was, this was a filter I bought from Astrodon that put in a filter wheel, yeah. It covers about 680 nanometers to 800 nanometers. In 2020, I started making YouTube videos again because I had settled into my job here. And then something really interesting happened to me, which is that I've been working on this video from about January through February into March. I was considering not even releasing it because by March, the Orion Nebula is starting to not be very high in the sky. So I was like, is this even worth releasing? But I did release it in March 2020. And then what happened in March 2020? Yes, the COVID lockdowns. And all of a sudden I was looking at this video and it was getting hundreds of thousands of views. And I was like, I have no idea what's happening here. But because I was just doing this as like a hobby channel, right? But it was getting so many views. And I think the reason was because I've always made pretty long instructional videos. And I realized that people were at home and were just watching this thing. They were actually watching like an hour-long video or 2 hour-long video. And then YouTube was like, oh, this is great. We're making a lot on this ad money. So they kept pushing this video. And it was just a really interesting phenomenon that I had no idea what was going on. But it sort of encouraged me to make more YouTube videos. And so I just started making YouTube videos on whatever topic came to mind and found that some of them would do well and some of them wouldn't. But it was really just like sort of my own curiosity, like, could I explain bit depth well? Are other people having this problem with a Rokinon 135 lens? All kinds of different little topics that would come to mind. And it would be interesting just to watch. Some of them would sort of get a lot of views and some wouldn't. At some point during this, when I was just making a lot of these videos, I turned on the ad partnership program on YouTube and realized you can actually make some pretty good money at this. I also turned on a membership thing on Patreon. And by 2023, I was actually making more money on YouTube and Patreon than my job here at the CFA. And that was, I guess, when I decided I'm going to move to New Hampshire and just do this. And I have been doing it since. Things have slowed down a little bit, but I'm still making enough money to live simply in New Hampshire off just YouTube and Patreon. One of the huge benefits to doing YouTube and being an astrophotography educator full time is people are always giving me new gear and software suggestions to try out. So I get to try out a lot of things. I didn't know about this piece of software until 2020. It's actually pretty old. I think it's something like 2011 or maybe even earlier. But by 2020, they had refined it enough that it was really a pretty good competitor to something like PixInsight, and it's completely free software. And for deep sky astrophotography, it could do things that I was always looking for in free software, but weren't available, like background extraction on a linear image, photometric color calibration, some of these things that are really pretty advanced and really cool. was available in free software. And because it's free and open, there were ways to extend it. So people were writing scripts. Naz, who's in the room right here, has written a number of scripts for Cyril that make it even more powerful. Then in 2023, they started offering some new tools that I thought exceeded even the capabilities of paid tools that I was using. So I feel like it got really exciting then. And I just wanted to show a little demonstration. Maybe this will work, maybe it won't. Let me see here. Of Cyril. Okay. So this is the North Star. This is Polaris right here. There's a nebula object around it called the Polaris Flare, which is also known as Integrated Flux Nebula. And it's basically just a reflection nebula, but instead of being reflected, the reflected light of one star, it's thought to be the reflected light of the entire Milky Way, which gives it just this sort of grayish color. But it's a pretty interesting dust object, and it's hard to bring out because once you start stretching, you'll see that there's all these stars, and this is a huge object, and it's very easy for it just to be completely overwhelmed by the star field. So what was introduced in Cyril 1.2 was this ability to add star removal right to the program. So if we go down here to star processing and then StarNet star removal, it has this StarNet is another free program built into it. And it offered some new options that I had never seen before. I want to go ahead and turn those on. So I'm just going to check the first three boxes here and run it. And then what it's doing right here is it's actually making two images. It's making an image of just the stars and of everything but the stars. Then it gives you this screen, and on the right-hand side, you're stretching just the stars. On the left-hand side, you're stretching what it calls the background or the nebula. And this to me was really intuitive and completely a new way of processing my images. And it's something that I always dreamed of ever since I was like sort of became familiar with JP Mezzaveno's work. Because before there was a lot more guesswork. Here you can stretch and immediately see what's going on right here on the left-hand side. Let me just quickly try to demonstrate this. Okay, so I'm gonna use these sliders to stretch up the image, and you'll notice that up here, this is called a histogram, and it's actually showing you the brightness values of all of the data in the image. We're just gonna do this in a couple stretches. Okay, so you can see here that I'm bringing out the nebula and not the star. So I'm just stretching the nebula on this side. And that allows me to bring up so much more structure here, as you can see. And then I can just bring in the stars to taste with this side. So I can just apply this, and I can go over here to the stretch factor on this side and start bringing in the stars to taste and apply. And I found with my style of imaging, I could really just do some of these linear steps like background extraction and color calibration, jump to this tool and be done. It made imaging simpler, but it also made imaging more powerful because I could bring out much dimmer details. Like the IFN around Polaris is a very difficult object. Processing it is very difficult. To me, this free tool made it so much easier.
Are you working with a color image here?
This is a color image. Yeah, it looks better on my screen. It's a little weird through Zoom, but
Yeah, up above, we've got better monitors. Up in the
oh, I see. Yeah. Oh yeah, and it doesn't even really look that color, but like I said, yeah, the IFN is sort of a grayish kind of nebula, so it's not a very colorful nebula. Also in 2023, actually, yeah, it was connected to Cyril. I know the connection I was making here. So in 2023, Cyril releases this new tool. one of the first things I did was I started going back to all my old data sets. I keep everything. I'm a digital pack rat, so I have every single file that I've ever captured. I go back to this old data set of the Cave Nebula, and I run that process that I was just doing where it takes out the stars on just the RGB. And this little blob right there looked really interesting. I had not seen that before. And I started looking up, what is this thing? And I looked up all kinds of different sources online. I did a literature review of professional literature, and I could find no reference to a reflection nebula around this star. So I did a follow-up with a much bigger telescope in a remote observatory, and I thought this object looks really cool. It's a little blue reflection nebula around the star B374 in Cepheus. I call it the Hummingbird Nebula because I feel like it has the shape of a hummingbird, with this being the long beak right there. And I think it's really cool. It's like the squid, it's like blue in front of red. And I think part of the reason it hadn't been found before in just colored images is because this hydrogen alpha behind it really dominates if you're just doing normal color imaging. So a faint reflection nebula is very easy to miss. There was another amateur discovery in 2023, though, that I want to highlight that's much more important than mine here, which is the M3103 emission by these French astronomers, French amateurs. This just looks so cool, and it was being found so close by geographically in the sky to M31 makes it even cooler, I think. But it's just this huge arc of O3 right above M31. There's been follow-ups where they actually found that it's this giant planetary nebula that actually has another part down here. And some of this HA emission is actually related to it too. So things like this, I think, are really interesting. And what you're going to find, I think, more and more with amateur discoveries is teams. So those first two amateur discoveries I mentioned, the soap bubble and the squid nebula, were individuals. A lot of the amateur discoveries happening today are going to be teams of amateurs teaming up. And there's a bunch of reasons for this. One of the good reasons is that they can really pile on the integration time. So they can use multiple telescopes and take hundreds of hours on some of these regions of the sky. A lot of times it's just lucky work. It's just pointing a bunch of telescopes to the same region of the sky, taking 100 hours on a filter just to see if anything pops out. This is another development in amateur astrophotography that's making this kind of thing more possible and just more common. These are remote observatories. So the professionals have been using remote observatories for a long time. In amateurs, it's becoming more and more common, and the price has been going down and down. This is one in Texas that's, I think, the biggest now. So you can see they have something like 10 buildings just full of amateur telescopes. I did bring a telescope down here, and I paid $200 a month for a peer rental. That may seem expensive, but before Starfront, I think the cheapest one was something like $500 or $600 a month. So the price has been going down. For me, personally, I would do it as like an extra thing, like to get even more data. If this was the only kind of astrophotography I was doing, I'd be bored out of my mind, because I really like being out under the night sky, actually fiddling with the telescope. So I think that I couldn't only do this, but it has been fun to do it as sort of an extra thing and see what it's all about. I don't know if I'm going to continue doing it forever. I also now have a backyard observatory that I built myself. This is a roll-off style observatory with two concrete piers in there. So this was another big motivation, I guess, for moving to New Hampshire, was to have like an actual place where it'd be worth building a backyard observatory. When I lived in Delaware, a lot of members of the club had, backyard observatories, and I was sort of thinking that would be nice one day to build one. So, and I liked every part of this process, like from the planning of it to the building of it. I did all the building parts myself. And so, and that was all just completely new to me, and it was a lot of fun to do something new in the hobby, because it's very different than just the telescope stuff. Okay, last thing that I want to talk about is back to that near IR imaging stuff. So Sony has been releasing some interesting sensors over the past 5 to 6 years. The first line of Starvis cameras are quite popular. Starvis 2 is just coming online, and they're making new innovations in CMOS sensors so that CMOS sensors can see better in the dark. And the motivation for this isn't us, it isn't astrophotographers, it's for security cameras mostly, right? So they're thinking, we want like really good security cameras where it doesn't matter how dark the scene is, that security camera can still pick up, you know, an intruder going into a building or whatever. But for us, we can get these sensors in astronomy cameras, and they're really, really good. They're very low noise, and they work really well in low light situations. One of the innovations they made was what's called a back illuminated CMOS sensor, where they moved the light receiving surface closer to the micro lenses and the filters up here, and it made a big difference in terms of low noise and just really beautiful images. These sensors, the IMX 533, 571, and 455, quickly became the most popular sensors in deep sky astrophotography. They really took over amateur deep sky astrophotography. This one, for instance, is the ZWO ASI 2600. This one is the ZWO ASI 533. These are two of the most bought astronomy cameras in the world now, because this line of Sony chips was so good. Just in the past couple of years, we now have Starvis 2, where they've done some really interesting things. It says they've adopted photodiodes with uneven surfaces, which enhance near-infrared light absorption. And then they also have done something with the pixel wells to make them deeper, to allow for the absorbed light of very long wavelengths. So the sensors so far that have come out with this technology, Starvis 2, are the 678 and the 585 in terms of astronomy cameras. And the 585 is the first one that has come out as a mono camera. I have this version of it, and I've just been incredibly impressed. This is the QHY Minicam 8M. I'm not trying to do a commercial for it, but I just wanted to tell you a little bit about it. One of the reasons I was impressed with this implementation of it is they came out with a system with custom filters. So they decided this sensor is so important to sort of the evolution of deep sky astrophotography that we're going to make a whole system with custom filters that are just the size of that sensor, and sell it as a kit. And it works incredibly well. It's about $1,000, and for mono imaging, where it comes with all the filters and the filter wheel, that's an incredible deal, especially considering this sensor is probably one of the best on the market today for really capturing things like the near infrared and H alpha and all those kinds of things. Another thing they did was they started releasing sort of exotic custom filters for it. Before they released this filter, the doubly ionized argon, you could get this filter, but it was either a custom job or you had to find it like for some other use case, some scientific use case, and adapt it to astronomy, right? You needed to maybe take it out of its filter threads and rejigger it. Now they've just come out with this, and it fits right into their filter wheel for $100. And it allows us on some planetary nebulae, like the Ring Nebulae, to see a different emission line than we're used to seeing. So we're used to seeing HA03 and S2 for astrophotographers. You can see here, these are all stretched the exact same. And the AR3 at 713 nanometers, well into the near IR, is almost as bright as the S2. I wasn't expecting this at all. I was expecting something very dim and noisy. When it came up and it was nice and bright, I was pretty shocked by that result. So this is my attempt at doing a color mapped image of that result. In this, I mapped the AR3 to green. And so you can hopefully see, okay, it just gives a little bit of a ring around the ring right there before we get into the HA and O3 outer shell.
What is the size of the chip in that camera?
It's 11 by 8 millimeters, so pretty small. This is at about 1,000 millimeter focal length, and this is the full chip area. Okay, then the last thing with this new setup, the QHY Minicam 8, is they released a Sloan photometric set. So remember back to my earlier experiments with the Sloan eye filter with the ASI 1600, and I wasn't getting any results. This has been this past couple weeks. I've set it on NGC 7822, which is a star forming region in Cepheus, and been getting much better results. So I'll just show a few examples of what I mean. So this one I thought was pretty interesting. You can just see this little dark sliver of dark dust, and the morphology of it is pretty similar between the Sloan G and the HA. And then what happens in the Sloan eye? It just disappears. And so I thought that's pretty interesting. It means that we can probably see through some dark dust clouds. And if there's any interesting structure behind those dark dust clouds in the infrared, maybe we'll be able to pull that out. So that's one example. And now here's, I think, an even more dramatic example. So this is the same dark dust cloud in NGC 7822. But look at how different the shape is in the Sloan eye filter. So we're seeing like sort of into the structure of a dark dust cloud. And for me, that's really exciting. I'm not sure exactly how I'm going to color map this yet, or what, what it means creatively in terms of the artistic final picture. But I'm finally sort of realizing the vision of imaging in the infrared. And I feel like that's sort of a new frontier for amateurs, at least. The professionals have been imaging in the infrared forever, and you can look at the infrared surveys. But for amateurs, the technology has always held us back a bit. And I feel like we're finally there, and with not so expensive cameras too. All right, thank you very much. And you can check out my YouTube channel right now.
Thank you.
So Nico, I just want to say that I've only been into astronomy and astrophotography for about 2 years, but I watched a ton of your videos early on. Got the Canon RA. I just wondered, are you aware of Canon still planning to bring online, more astrophotography mirrorless?
I'm not aware exactly, but I'm pretty sure they will, because they've been just so long been doing it with the 20D, then the 60D, then the RA, and there's usually something like a 7 to 8 year gap between the products, but I bet eventually they will make another astronomy camera. And I think like the RA, it'll probably be that sort of limited release where it's out for a year or two and then they discontinue.
I think most modern, very modern cameras, it has a back illuminated now.
Yes, yeah.
They stopped that. That was about 3 years ago.
Yeah, that's true. The comment was most modern CMOS cameras are now back illuminated. So that technology that was first sort of introduced by Sony is really took over the industry.
Just for everybody else's camera.
Yeah, right. Yeah.
What sort of computer setup are you using? Are you Windows based or Linux?
I have all of them. For a long time, I was presenting on a Mac, and for a long time my sort of daily driver computer was Mac. And I was working on some big mosaic, and it was, processing and stacking for something like 20 hours. And then I just got this message, ran out of application memory. And so, there was not enough random access memory for it to actually finish the process. I tried it over and over again and still kept getting that message. So because I knew I wanted to work on these big mosaics into the future, I did build a desktop PC with like 128 gigabytes of RAM because I was like, I need something that will actually handle these big projects. So I do have a Windows machine just for basically astrophotography process.
Do you mostly use, I'm sorry,
Okay.
Cyril, or do you use Pixel Insight?
Yeah, I use it all. I will usually start in Cyril, because it's so fast and it will give me an idea of, what I need. For big projects where I'm working on with many different filters, there are some advantages to Pix Insight where you can open many windows and do different things, that Cyril doesn't have yet. So then I usually do move to Pix Insight.
What kind of image acquisition software do you use?
I'm still on one called Sequence Generator Pro, just because it's the one I learned a long time ago. Most people, though, today would be better off starting with one called Nina, which is free. And the reason you'd be better off is because there's a huge community behind it, and they're always making new plugins and things like that. So if you're on a Windows PC, I would say Nina. If you find that downloading drivers and all this stuff is like too complex, there's another good product. If you're in ZWO land, you have a ZWO camera called the ASI Air, which is good for acquisition.
Sony has now introduced a line of shortwave IR sensors
Oh, okay.
related to stargaze, but these things work in the sort of 1.5 to 2 micron range.
Wow.
So you can't use your same lenses, you have to use bigger optics or invest in completely different optics, and then Scientific sells some lenses up to 200 millimeter focal length, in fact.
CWO has a pair of them bodies, but they're pretty pricey, for 18 grand.
Wow.
Ah, okay. Do you know if, have you heard about using gold plated mirrors for that? Someone was telling me about that.
Gold works really well.
That can work, silver, protective silver.
Okay.
A classic for infrared optics is gold or copper.
But that's pretty far north.
Yeah, that's pretty interesting. I did 1.5 to 2 is a lot further than I could.
You
Yeah.
can see through water in the atmosphere to use it for like long surveillance, horizontal, get good contrast for kind of
Much through haze too.
Yeah.
I wonder if in, our lifetimes that 18,000 will come down to a few $1,000 or something. Yeah. All right. Well, thank you very much.
Thank you.
Thank you, everyone. So we are coming to the close of the meeting. Next meeting, November 13th. See you there.